Hi everyone, I am Yamazi binti Mufi. Today I will present about flood hazard modeling and flood forecasting. In this subject, riverine management and mitigation flood by Dr. Saiful Iskandar. These are my table of content. First, we will go into flood hazard modeling. Second, flood forecasting. Third, methodology for both. And last but not least is my references. Flood hazard. Flood hazard modeling was developed to generate and document maps presenting the spatial distribution of flood hazard for the whole atlas of disaster risk. The producer used to spatially distribute flood hazard combines the extent of past flood event with the spatial distribution of causal factors. The combination enables the calculation of a weighted score for each individual causal factor. Flood forecasting. Flood forecasting is a process of estimating and predicting the magnitude, timing, and duration of flooding based on known characteristics of river basin. It also uses of forecasted precipitation and stream flow data in rainfall runoff and stream flow routing models to forecast flow rates and water level for periods ranging from a few hours to days ahead. These are components of flood forecasting. First step is collection of real-time data. Next is preparation of forecast warning and information messengers. And next is communication and dissemination of such messengers. First step is interpretation of the forecast and flood observation. And then in response to the warnings. And lastly is review and improvement of the system. These are the functions of flood forecasting. First is a prerequisite for successful mitigation of flood damage. Second, plays vital role in flood management when no preventive or defense measure can be completely effective. Third, increases flood resilience of the flood affected people. Then, evacuation of vulnerable groups and moving of assets. And then, installation of flood resilience measure. Lastly, the function of flood forecasting is temporary flood defense. Methodology of flood mapping and forecasting. We move along to this slide is flood hazard mapping is used to determine the area susceptible to flooding when discharge of a stream exceeds the bank full stage. It also using historical data on a river stages and discharge of previous floods along with topographic data. Maps can be constructed to show areas expected to be covered with flood water for various discharges or stages. So these are the schematic of method flood hazard mapping. There will be first step is meteorological data and will undergo to stream flow, next extreme events, after that flood extent, and last but not least is socio-economic impact, which the next picture there will be the result of flood hazard mapping.
Rivers flow through the heart of many communities in Alberta, and flood maps are important tools that help us understand and manage flood risks. Flood maps identify where water will flow during a flood and what land could be flooded for different sized floods. Making accurate flood maps requires detailed river and floodplain information and a lot of science and engineering. Hydrologic assessment estimates a range of potential flood flows, and hydraulic modeling calculates water levels along rivers for those flows, which we then use to map floods through our communities. We can map small floods and large floods, but to make a map for a specific sized flood, we need to choose a specific river flow to model. How do we know what river flows to model and what floods to map? First, we investigate historical floods and analyze precipitation and flow data to understand what kinds of floods we might see in the future. Statistical analysis of recorded flows at river gauges across Alberta gives us an idea of what sized floods have different chances of occurring in any year. The next step in making a flood map is building a hydraulic model using surveyed river and ground data, bridge and culvert information, and detailed floodplain topography. We calibrate the model using knowledge about river and floodplain characteristics and measured high water marks from past floods. When a hydraulic model can reasonably simulate past floods, we can be confident in the water levels it calculates for different flood flows. Finally, we make flood maps by transferring the model results onto base maps to identify areas that would be flooded. Maps can convey all kinds of data and tell a variety of stories. Different maps have different uses, and flood maps are no different. Some maps support emergency response during a flood, and other maps are used to plan future development and help build safer communities over the long term. Most flood maps focus on floods caused by high river flows, as we see after major summer rainstorms. But maps can also show areas at risk from ice jam floods or document the extent of historic floods. Some maps are relatively simple, while others divide flood areas into zones to highlight special features or to help with land use planning and regulation. Flood maps can also be combined with infrastructure, social or economic information to help better understand flood risks and vulnerabilities. Flood maps are important tools that all Albertans can use to improve flood resiliency in our communities. Understanding how and why different types of flood maps are made is another way to learn about your flood risk and become river smart. Thanks for watching.
Then move along to flood forecasting methods. First step is define model purpose, and then we specify modeling context. After that, conceptualize system which specific data of the flood. And in step 4 is determine how model structure and parameters to be found. 5 is to determine how model structure and parameter to be found. And next, step 6 is choose performance criteria. And in step 7 is identify model structure and parameter values. And then validation and testing.
Flood Forecasting and Warning System atau FFWS. Untuk pengumpulan data aktivitas pengairan, mengurangi dampak negatif akibat banjir, mengantisipasi musim kemarau khususnya bagi area irigasi, serta manajemen sumber daya air dalam cakupan yang luas, maka FFWS mampu melakukan pengumpulan data real melalui rain gauge, water level sensor floating type, dan water level pressure transducer. Melalui ketiga jenis alat ini, akan diperoleh data yang dapat didisplay melalui selular maupun database server untuk diteruskan pada FFWS Management Center ataupun public user seperti internet demi kepentingan peringatan dini atau National Early Warning System.
Thank you. Stay at home. Bye.